In this lecture, we will see problems related to elementary transformations. There are basically two elementary transformations, row reduced echelon form and column reduced echelon form. In row reduced echelon form, we will reduce the given matrix using row transformations or row-wise operations. And in column reduced echelon form, we will reduce the given matrix using column operations or column transformations. We can see in detail row reduced echelon form. Find the rank of a matrix by converting it into row reduced echelon form. The matrix is our aim is to reduce this given matrix and into an ideal form, which is a 3 by 4 identity matrix. And we give emphasis on the following facts: that the first element of the first row should be 1 and all the elements beneath this one should be zeros. And the second element of the second row should be 1 and all the elements below this one should be zeros. And the third element of the third row should be 1, like that. We can look. First step is making the first element of the first row 1. Since in the given question is already 1, we can write this first row as it is. To make all the elements below this 1 to zeros, we can use a row transformation. R2 gives R2 minus 2 R1. That is 2 minus 2 into 1, 2 minus 2 0, 4 minus 2 into 3, 4 minus 6 minus 2, 5 minus 2 into 4, 5 minus 8 minus 3, 8 minus 2 into 7, 8 minus 14, that is minus 6. And to make the third row, first element of third row 0, we can use the row transformation. R3 gives R3 minus 3 R1. 3 minus 3 into 1, that is 3 minus 3 0, 1 minus 3 into 3, 1 minus 9, minus 8, 2 minus 3 into 4, 2 minus 12, minus 10, 3 minus 3 into 7, 3 minus 21, that is minus 18. Next, we have to make the second element of the second row 1. For that, use the row transformation. R2 gives minus 1 by 2 R2. Multiply all the elements of the second row by minus 1 by 2. Multiply all the elements of the second row by minus 1 by 2. Then we get 0, 1, 3 by 2, 3. We have to make the second element of the third row 0. For that, use the row transformation. R3 gives R3 plus 8 R2. Then we get the third row as 0, 0, 2, 6. Now we have to make the third element of the third row 1. For that, use the row transformation. R3 gives 1 by 2 R3. Then the third row becomes 0, 0, 1, 3. We have got the reduced matrix. And since the reduced matrix has 3 non-zero rows, therefore the rank of the given matrix is 3. Rank of a matrix is determined by the number of non-zero rows in its reduced form. Next question. Given a matrix, reduce the given matrix using row reduced echelon form. Given matrix is first step is to make the first element of the first row 1. Since it is already 1 in the given question, we can write the first row as it is. Next aim is to make all the elements below this one to zeros. Therefore, use the following row transformations. R2 gives R2 minus 2 R1. Therefore, the second row becomes 0 minus 1 1. Use the row transformation. R3 gives R3 minus 3 R1. Therefore, the third row becomes 0 minus 1 1. Use the row transformation. R4 gives R4 minus 2 R1. And the fourth row gets updated as 0 minus 3 3. Next step is to make it the second element of the second row 1. For that, use the row transformation. R2 gives minus R2. Let us multiply all the elements of the second row with minus 1. Therefore, we get 0 1 minus 1. And use the row transformation. R3 gives 2 R3 plus R1. And the third row is updated as 1 0 3. Now we have to make the third element. Now we have to make the first element of the third row to 0. For that, we use the row transformation. R3 gives R3 minus R1 and becomes 0 minus 2 2. Next, we have to make the elements below this 1 to zeros. For that, use the row transformation. R4 gives R4 plus 3 R2. And the fourth row becomes zeros. Next, we can use the row transformation. R3 gives 1 by 2 R3. Then the third row becomes 0 minus 1 1. And we can make the third row also zeros by using the row transformation. R3 gives R3 plus R2. Therefore, third row becomes zeros. Therefore, we have got our reduced matrix and it contains only 2 non-zero rows. Therefore, the rank of the matrix is 2. Since there are 2 non-zero rows. Next question is reduce the given matrix using row register echelon form. And the given matrix already contains 1 as the first element of the first row. Therefore, we can write the first row as it is. And we have to make all the elements below this one to zeros. So use the row transformations. R2 gives R2 minus 2 R1. The second row gets updated as 0 minus 1 1. Use the row transformation. R3 gives R3 minus 3 R1. Third row becomes 0 minus 1 1. R4 gives R4 minus 2 R1. And the fourth row becomes 0 minus 3 3. And we have to make the second element of the second row 1. So we can use the row transformation. R2 gives minus R2. Multiply the second elements of the second row with minus 1. So that we will get the second element of the second row as 1. Second row becomes 0, 1, minus 1. Our next aim is to make all the elements beneath this one to zeros. Therefore, use the row transformations. R3 gives R3 plus R2. And the third row becomes zeros. And R4 gives R4 plus 3 R2. And the fourth row becomes zeros. And this is the reduced matrix. And since the reduced matrix contains 2 non-zero rows, therefore the rank of the given matrix is 2. Next question is find the rank of the matrix by reducing it into using row reduced echelon form. Here the first element of the first row is 1. Therefore, we can write the first row as it is. Next step is to make all the elements below this one to zeros. So use the row transformation. R2 gives R2 plus 2 R1. And the second row becomes 0, 8, minus 7, 30. And use the row transformation. R3 gives R3 minus 5 R1. And the third row becomes 0 minus 8, 7, minus 30. And we can see that if we add this second and third rows, then we will get zeros. Therefore, use the row transformation. R3 gives R3 plus R2. And the third row gets updated to zeros. And use the row transformation. R2 gives 1 by 8 R2. And the second row becomes 0, 1 minus 7 by 8, 13 by 8. And we can see that we cannot reduce it furthermore. And this is a reduced matrix. And there are two non-zero rows in the reduced matrix. Therefore, rank of the matrix is 2. We can see the remaining problems in the next class. Thank you.